good day to everyone. Let's take a look at a question on AP and GP from Dunman High 2023. Part A of the question says the sum of the first n terms of a series is given by Sn equal to 3n and plus 2. Show that this series follows an arithmetic progression. Sn equal to 3n and plus 2. And to show that it's an arithmetic progression, we can actually either make use of un plus 1 minus un, or we can make use of un minus 1. And our objective is to show that any general term here, subtract by its preceding term, always give us a constant. And once we will be able to show that it's a constant, that means to say that it will be a AP progression. And the value of the constant actually will just be our common difference. And since for this question, since we only have Sn, we need to find out what is our un via this formula, which is un equal to Sn minus 1. Sn, I can just sub inside this expression. Sn minus 1 basically is just to replace all the n I see with n minus 1. Doing a bit of simplification, I will end up with 6n plus 3. Our general term will just be 6n plus 3. And now perhaps I can just make use of our second expression here. Un will just be 6n plus 3. Un minus 1, just replace all the n I see with n minus 1. 6n minus 1 plus 3. Simplifying a bit, I will end up with a 6, which is very good because once I show that this is a constant, that means to say that this un will just be a AP. And the common difference, right, of this sequence actually will just be equal to 6. Because when we are using un minus away with its preceding term, that difference, right, actually will just be the common difference. Let's look at part B now. Part B says the second, seventh, and the nth term of a series in part A are the first three consecutive terms of a GP such that the nth term is given by Vn. Find the value of n and explain whether the sum to infinity of the GP exists. So when we are given this type of question which have a relation between an AP and GP, usually I will prefer to write down this information in a tiny table form. We will have a AP here, we have a GP. This is the second term, U2, seventh term, and the nth term. And it says that the second term of an AP is the same as the first three terms of a GP. This is the first three terms. Your GP is V1, V2, V3. And we know that for GP, it has the same common ratio. That means to say, if I use V3 divided by V2, will just be the same as V2 divided by V1. V2 divided by V1 equal to V3 divided by V2. And we can just replace this with our AP since we have our information on our AP and we don't have anything about GP. So maybe we can just replace this entire expression with all the AP information, which is V2 will just be equal to U7, V1 will be U2, and V3 will be UM, and V2 will just be U7. And since this U is our general term of our term of our AP, we can make use of the AP formula. Like for this U7 is the seventh term of our AP is given by A plus 6D. U2 will just be A plus D. UM will just be A plus n minus 1D, and U7 will just be A plus 6D. And all we need to do is to sub in the values of the first term and the common difference, and hopefully we can solve for the value of n. From our previous part A of the question, since we have the general term which is u n equal to 6n plus 3. I know the first term is equal to putting the value of n to be 1, so I will get 9. And the common difference will just be 6. With this information here, we can just put it into this expression here. I will get 9 plus 6, d is 6. This will just be 9 plus 6 equal to 9 plus n minus 1, d is 6. This will just be 9 plus 6 times 6. So for the left hand side, this is 45 over 15. This is 9 plus 6n minus 6. This is 45. Let's do a bit of simplification. I will end up with 1, 3, 5 equal to 9 plus 6n minus 6. I will just get 1, 3, 2 equal to 6m, and solving m, I will be able to get m equal to 22. That will be my answer for my part B, the first part. And there's a second part says that explain whether the sum to infinity of this GP exists or not. Then we need to make use of our knowledge on sum to infinity. In order for a GP sum to infinity to exist, it must fulfill one requirement. The requirement is the common ratio must be lesser than 1. The modulus of common ratio must be lesser than 1. Here we can able to find out what is our common ratio either from here or here. It's just be this equal to common ratio. This is also equal to common ratio. In fact, actually, I can just see the common ratio is this portion here, because this will just be our V2 divided by V1. This will be my common ratio. The common ratio will just be 3 in this scenario. And since common ratio R equal to 3 doesn't lie within this, therefore, sum to infinity doesn't exist. Alright, let's take a look at part C of this question. The f term of another GP is given by Wn equal to e to the power of 5 plus nx x plus 1. Find the range of values of x such that this GP converges. Basically means when the question says that a series converges, it means that a sum to infinity do exist. If we say that the series diverging, it means that the sum to infinity does not exist. And since this question that we are dealing with is like a GP, and we know that in order for a sum to infinity to exist, the common ratio, the modulus of the common ratio should be less than 1. Let's write down the equation first. Wn will just be equal to e to the power of 5 plus nx x plus 1. And the question says it's converging, so we know that the common ratio is less than 1. To determine the common ratio from a general expression, we can just use Wn divided by its preceding term, which is equal to e to the power of 5 plus nx x plus 1 divided by e to the power of 5 plus, replace all the n I see here with n minus 1, I will get this. And we are supposed to simplify this expression here. It's a bit complicated, but no choice, we still have to simplify this. Let's perhaps break up this part first. So I'll get e to the power of 5 times e to the power nx x plus 1 divided by e to the power of 5 times e to the power n minus 1 x plus 1. E to the power of 5 is constant, so let's cancel. And division for this, I will end up with e to the power nx plus x plus 1 minus n minus 1 x plus 1. Factorizing out the x plus 1, I will get e to the power of n minus 1 x plus 1, which will just give me e to the power x plus 1. This will be my common ratio. And it will fulfill this inequality here. I will get modulus of x plus 1 less than 1. Right, and usually if the question did not mention that anything about calculator, for inequality, by default, I will just solve using our GC because I think it's a much better way than using an algebraic method to solve this. And by using our GC, I have sketched this. Let me just replicate this here. I will have a graph that looks like this. This will be my equation, e to the power x plus 1. And the line y equal to 1 will actually cut across this portion here, y equal to 1. Okay, and if I want it to be this to be less than 1, that means this is the region that I'm interested in. And from our GC, I can find that this value here will just give me equal to minus 1. So therefore, the range of values of x that give me a converging series will just be from minus 1 to 0. Okay, now let's look at part D of this question. So part D says that using x equal to minus 0.5 in part C, and given that the sum of the first n terms of the GP in part B first exceed the nth term of the GP in part C, given by this expression, determine the least value of n. All right, perhaps I can just recall what is our GP in our part B first. The general term for our part B, let me just erase this part first. Is our Vn expression. And Vn expression for this, I'll know that our first term will be equal to first term V1 will be the same as U2. And is given by to be 9 plus 6. This is like a plus D. This is our the series in our first part A, which is an AP, which is given by A plus D. And first term will just be 9, and common difference will just be 6, like what we have found previously. So our V1, the first term, our GP is given to be 15. And for the common ratio, we have already found that actually is equal to 3 from our part B. I can just write down our general term for our GP, for our Vn. So I will get 15, 3 to the power n minus 1. And for our part C of the GP is given to be Wn equal to e to the power of 5 plus nx, x plus 1. And in this scenario, our n is x is given to be minus 0.5. I'll just replace this with minus 0.5. This is 0.5. And what the question wants, right, is the summation of VR greater than Wn. Summation of VR is just like a summation of a GP. We can make use of the sum to n terms of a GP formula, which is given to be Sn equal to A, Rn minus 1, R minus 1. Or you can make use of this, it doesn't matter. Maybe I'll just go for this question. Let me just erase this first. So for the left hand side, I will be summing the GP of this one. I will end up with 15, 3 to the power of n minus 1 over 3 minus 1. And the right hand side will be this expression here, e to the power of 5 plus n minus 0.5, 0.5. This one I can just rewrite it to be equal to 2. What we need to do is to solve this inequality, and again, I will be using our GC to solve this. And one thing, right, when we are looking at this expression, the unknown that we are trying to find actually is a constant. And I mean, it's a constant integer. If it's an integer, usually I will try to make use of a table to solve instead of the graph. Although both is workable, but my preference is to use the table. Let's take a look at our GC now. So from our GC, I've keyed the left-hand side of this equation as my y1, the right-hand side of this equation as my y2. And from here, I'll just go to second graph to generate the table. And what we require is to find the least value of n such that the left-hand side, the y1, will be bigger than the y2. This is my y2. And from here, actually, I can immediately see our answer is just the 3. Can you see that this one, the blue one, the table, this is the first time that the y1 exceeds the value of the y2, 195 against 70.105. So our answer actually is just n equal to 3. But when we are doing our presentation in our exam, we have to draw out the table to illustrate this. I will have this. This is our n. And I have to write down the first 3 rows, the one before it, and the one that I want, and the one after it. It will be 2, 3, 4. This will be my expression here. This entire expression you have to write down here. Same thing here, you have to write down the entire expression here, y2. And we will just write down all the values, which is just 60, 195, 600, 90.017, 70.105, 54.598. This will be my answer. So therefore, this n will be equal to 3.